Let's start with Jefferson's method. Jefferson's method was the first method used, and I've got directions here for how we would use it, but it's almost easier to see it in the course of an example instead of just reading through the directions for using the method. So let's use an example and we'll go through the directions for using the method as we do the example. Now we're going to use a hypothetical country of 3 states because if we used our real country with 50 states, it would just take too long to do the numbers. So we're going to use 3 states just to get an idea how this process works. And we're going to say these 3 states have a House of Representatives with 100 seats. So we want to apportion those 100 seats among the 3 states based on population. All right, so the first step in terms of doing Jefferson's method, and in fact all of the methods, is to find a standard divisor and then the standard quota for every state. So we're going to do the standard divisor first. The standard divisor is always going to be the population, the total population, which in this case is 13,490, divided by the total number of seats you have in Congress, so 100, the things we want to divide up among that population. So 13,490 divided by 100, just use your calculator, we get 134.9. And I'm going to keep that decimal, usually with a standard divisor, out to about the first decimal place. Now, what we're going to do next is find the standard quotas for every state. So the standard quotas are the decimal equivalent of how many seats they would get. So that includes the decimal. So we're going to take each population and we're going to divide each population by the standard divisor. That's why it's called a divisor, is because we're going to divide by it. So 1,280 divided by the standard divisor of 134.9, we get 9.49. And then do the same thing for 210, and we get 1.56. So that's State B's standard quota. State C has got a lot more people in it, 12,000. If we divide it by 134.9 rather, we get 88.95. Now, if we've done this correctly and haven't made a mistake in our calculators, when we add up the standard quotas, we should get back to 100 seats. So let's double check this. So if we add these up, 9.49, 1.56, 88.95, we do get 100.00. Again, it is possible to have a little bit of round off error, but you should be really close, like 99.99 or 100.01 should be really close. In this case, it does come out exactly to 100. All right, now lower quotas is what we do next in Jefferson's method. Jefferson's method said truncate or cut off the decimals on the standard quotas. So what Jefferson wants to do is just cut off the decimals. Another way of saying that is you round down. So 9, 1, and 88, you literally just cut the decimals off. Now we add these up. 9 plus 1 plus 88 gives me 98. And if we don't get 100, and we've only, in this case, apportioned 98 of the seats, we want to take and distribute out all 100. So this is too small. If we don't get all 100 seats, what we do is we create what's called a modified divisor. Okay, a modified divisor. We're going to leave off the standard divisor and start dividing by something else. So how we're going to choose this modified divisor, this new divisor, is the modified divisor should be lower than the previous divisor if the total is too low. The modified divisor should be higher than the previous divisor if the total was too high. Now my total was too small or too low, so I should go lower. Right now I've got 134.9, so why don't we take that down to 130? So we're going to use a modified divisor. So we're going to create modified quotas by dividing by 130 as our new divisor. So we're going to take each of our populations again. So we're going to take the population and we're going to divide by 130. So 1,280, take that population, divide by 130, and we're going to get 9.84. And then 210 divided by 130, we get 1.62. 12,000 divided by 130, we get 92.31. And remember the idea, once we get the modified quota, or the quota, the way Jefferson's method says to take care of the decimal is you just cut it off. So then my whole numbers would be 9, 1, and 92. Now if we add those up, we get 102. So that's too large. It's too high. Because remember, I wanted 100 seats. So what we have to do is, if we don't get the value that we want, is we start again. So the whole process starts again of choosing another new value. So we're going to do this again. We're going to do another modified quota calculation for all of the states, but we're going to use a new modified divisor. Now I started with 134 and then I went to 130. 134.9 was too small, 130 was too large. So I need something in between. Why don't we try 134? So let's go back a little higher, because maybe I went too high, too low, way too low before. So if I try 134 as my new modified divisor, go back to the population values again and redivide. So 1280 divided by 134 gives me 9.55. And again, if you want to, you can immediately cut off the decimal, because that's what Jefferson's method does. Then 210 is the population divided by 134 gives me 1.57. So that again cuts down to 1. And then the last value, 12,000 divided by 134, gives me 89.55, which cuts to 89. So if I add that up, I get 99. So I'm still too small, but I'm closer. So I was too small by 2, then I was too large by 2, now I'm too small by 1. So we're getting closer. We now know that we need to still go smaller. Remember, if our total is too low, we want to go lower, but maybe not that much. Maybe just go down to 133. So you keep doing this process of doing new modified quotas with new divisors, but you choose your divisor very specifically to it's a kind of a hot-cold strategy of narrowing your way down to the real value. So once again, take the population. Now we're dividing by 133. So 1280 divided by 133 gives me 9.62. Cut off the decimal, that's 9. Then we have 210 divided by 133 is 1.62. Cut off the decimal, that's 1. And then the last one, 12,000 divided by 133 gives me 90.23. Cut off the decimal and we get 90. So 9, 1, and 90 now give us 100. So our true apportion, or the portion that Jefferson's method would have us use, is that State A gets 9 seats in Congress, State B gets 1, and State C gets 90. So this is Jefferson's method. You have to cut off the decimal, but if you don't get the total you want, you redivide. You divide with a new divisor until, once you cut off the decimals, it comes out to exactly the right value. Jefferson's method was used for about 50 years, but it was eventually abandoned because it had some issues. In particular, it tended to favor states with larger populations and sometimes gave them more than their fair share of representatives in Congress through the apportionment process. If we look at this large State C from our last example, State C had the much bigger population than the other states. It had 12,000 people, whereas the other states had at most 1,200 or 210 people. If you look at their standard quota, what we originally had for State C had a standard quota of 88.95. So technically, if we were looking at giving them decimal seats, they would get exactly, the ideal number of seats would be 88.95. If you could give them a decimal number of seats, this would be the ideal. But we can't give them an ideal number of seats. We can't give them a portion of seats. We have to give them a whole seat. So the rule is generally that we should give them either that value rounded down or that value rounded up. So you would look at the whole numbers on either side. If you look at what State C got in with Jefferson's apportionment method, though, you see how it ended up going beyond 89. State C should have gotten 88 or 89 seats. They ended up getting more than that. They got a lot more, well, got exactly one more. They got 90. So that was beyond the 89 that would have been fair. So this tended to happen with Jefferson's method, especially with larger states. And state sees apportionment like this, where you get more than what would be fair, is something that we call a violation of the quota rule. Now, with apportionment, one way of measuring fairness is with this quota rule. And the quota rule states the final apportionment for a state should always either be the whole number from rounding a standard quota down, that's what we call truncating when you cut off the decimal, or the whole number from rounding the standard quota up. So in this case, state C should have either gotten 88 or 89 seats. Because they got more than that, they got something that wasn't 88 or 89, it was a violation of the quota rule. So in terms of deciding whether something is fair, generally what sociologists do is they compare the final apportionment to the standard quotas to check to see if the quota rule was violated or not.